In this lesson, we're going to cover arc length. The definition for arc length is if f prime is continuous on the closed interval from a to b, then the length of the curve y equals f of x from a to b is given as the integral from a to b, the square root of 1 plus f prime of x squared dx. Instead of f prime of x, we can also use Leibniz's notation dy dx right here. And then we have a note: if a curve has the equation x equals g of y, and y is between c and d, and g prime of y is continuous, then by interchanging x and y, we get this formula for length: the integral from c to d of the square root of 1 plus g prime of y squared dy. And then similarly, instead of g prime of y, we can also rewrite this with Leibniz's notation as dx dy. This example says find the length of the given curve on the interval. We have y equals 1/3, the quantity x squared plus 2 to the 3/2, from x equals 0 to x equals 3. So first thing we're going to do is we're going to take the derivative of y. So I'm going to drop down this 1/3. And then we're going to take the derivative of this function. So to take the derivative, we're going to use the chain rule. So we're going to bring down the 3/2, leave the inside the same, x squared plus 2. And then we subtract 1 from the exponent, which is the same as subtracting 2 over 2. And finally, we take the derivative of the inside, which is 2x. So at this point, these 3's are going to cancel, and the 2's also cancel. So for the derivative of y, we get x square root of x squared plus 2. Okay, we're ready to plug this into our length formula. So our length is going to be the integral from 0 to 3 of the square root of 1 plus the derivative squared. So next we're going to take this expression and square it. Since these are a product and we're squaring it, remember it's x square root of the x squared plus 2 times itself. So the x and the x make x squared. And the square root of x squared plus 2 times itself is just going to be the expression without the square root. So again, it was quantity squared, so x times x makes x squared, and a radical times itself just makes the expression without the radical. All right, at this point, we're going to distribute. So x squared times x squared is x to the 4th. X squared times 2 is 2x squared, and then we're going to drop down this plus 1. At this point, we want to factor this. So x squared times x squared makes x to the 4th, and then 1 times 1 makes 1, and you can see that this is 1x squared plus 1x squared, which combines to 2x squared. So this expression factors to x squared plus 1 quantity squared. Okay, next, the square root and the square, they undo each other. So now we have this expression, the integral from 0 to 3 of x squared plus 1 dx. So finally, we can integrate. So when we integrate x squared, we get 1/3 x cubed, and when we integrate 1, we get x. So now we're going to evaluate this by plugging in 3, subtracting, plugging in 0. So for our final answer, we get a length of 12. This example says x equals y cubed over 3 plus 1 over 4y, and we're finding the length of this curve from y equals 1 to y equals 3. So before we start, I moved this y to the top, making it y to the negative 1, and now we're going to take the derivative. Since this equation is x with respect to y, we're taking the derivative of x with respect to y. So the derivative of y cubed over 3 is just going to be y squared. Right here, the derivative is going to be negative 1/4, and then y to the negative 2. So our derivative is y squared minus 1 over 4y squared. Let's go ahead and plug this into the length formula. So our length formula is the integral from 1 to 3, the square root of 1 plus the derivative squared. So at this point, we need to FOIL this out, so I'm going to write that on the right. So when we FOIL this, we get y to the 4th. For the outer term, when you multiply them, the y squared and the y squared cancel, so you just get negative 1/4. And the same thing goes for the inner terms. The y squareds cancel, and you also just get negative 1/4. And the last term times the last term is going to be positive 1 over 16y to the 4th. When we combine these negative 1/4, we get negative 1/2. So we're going to take all of this and plug it in right here. So now we're going to combine this 1 and negative 1/2. So 1 take away 1/2 is going to be positive 1/2, and then we drop down this 1 over 16y to the 4th. So next we need to factor this. So we get that y squared times y squared makes y to the 4th. And 1 over 4y squared times 1 over 4y squared makes 1 over 16y to the 4th. And these both need to be positive. So this expression factors to y squared plus 1 over y squared quantity squared. So finally, this square root and this square are going to cancel. So we just have the integral of y squared plus 1/4 y to the negative 2. And now we're ready to integrate. So the integral of y squared is 1/3 y cubed. For this expression, I'm going to drop down this 1/4. And the integral of y to the negative 2, we're going to add 1 to the exponent, making y to the negative 1. And then we divide by this new exponent, which just brings in a negative 1 to the problem. So we have 1/3 y cubed minus 1 over 4y. So we're ready to evaluate. We're going to plug in 3 minus plugging in 1. So for our final answer, we get 8 5/6, or 53 over 6. For this example, we have y squared equals x cubed, and we're finding the length of this curve from x equals 4/3 to x equals 32 over 9. Before we do anything else, I want to solve for y, so we get plus or minus the square root of x cubed, and that's the same as plus or minus x to the 3/2. And in case you wanted to plug this into a calculator to see, you would type y equals positive x to the 3/2 and also negative x to the 3/2. So the positive x to the 3/2 looks like this, and negative x to the 3/2. And then when we're trying to find the length from 4/3, which is 1 1/3, to 32 over 9, so for example, it would be from here to here and also from here to here. So what we're going to do is we're going to find just the length from here to here, and then we're going to times it by 2. So again, we're just going to find the length right here, so that would just be y equals x to the 3/2. So I just wrote that out, find the length of the top part of the curve, so again, that's this one right here, which is y equals positive x to the 3/2, and multiply that by 2. Okay, so using this curve, we're going to take the derivative. So dy dx equals 3/2 x to the 1/2. And now we're going to plug this into our length formula. So we have the integral from 4/3 to 32 over 9 of the square root of 1 plus, this is the derivative squared. So here's our length formula, so we're going to square this. So to integrate this, we're going to use u-substitution, and we're going to let u equal everything underneath the square root. So we have u equals 1 plus 9/4 x, so du dx equals 9/4, and then we're going to cross multiply, and then because this is a proportion, we're going to bring this dx up to the right. We're going to bring this 4 up to the left, and we're also going to bring this 9 down to the left. Next, we're going to convert our limits. So we're going to take this upper limit, and we're going to plug it in for x. So at this point, we can reduce these fractions, and we just get 9. Next, we take 4/3, and we plug it in for x. So we have 1 plus 9/4 times 4/3, and we get 4. So now we're going to plug everything in up here. Everything's plugged in, so we're going to pull this 4/9 to the front, and rewrite this u as u to the 1/2, and now we're ready to integrate. So u to the 1/2, when we integrate, we get 2/3 u to the 3/2. I'm going to pull this 2/3 to the front. So now we're going to plug in 9 minus plugging in 4. The square root of 9 is 3, 3 cubed is 27. The square root of 4 is 2, and 2 cubed is 8. So we get 152 over 27. And then we take this and we're going to times it by 2 to get the bottom half of the length. So 2 times 152 over 27. So our final answer is 304 over 27. This example says g of x equals the integral from 0 to x of the square root of cosine of 2t dt. And we're going to find the length of this curve from 0 to pi over 6. So first we need the derivative of g. To take the derivative right here, because we have the integral from a constant to a variable, we're going to apply the fundamental theorem of calculus. So since these are in the correct order, the constant's on the bottom, the variable's on top, when you take the derivative of this integral, the two operations undo each other, and we take this x and we plug it in for t. So the derivative of g is going to be the square root of cosine of 2x. So now we're ready to set up the length formula. Okay, so everything's plugged in. This square root and square are going to cancel. So now we have the integral from 0 to pi over 6 of the square root of 1 plus cosine of 2x dx. So next we're going to use the double angle formula, which is cosine of 2x equals 2 cosine squared of x minus 1. So we're going to take this and plug it in right here. So now we can cancel this 1 and this negative 1. So inside here we get the square root of 2 times cosine squared of x. And we can break this up to the square root of 2 times the square root of cosine squared x. And this square and the square root are going to undo each other. And now we're ready to integrate. And finally, we're going to plug in pi over 6 minus plugging in 0. Sine of pi over 6 is going to be 1/2, and sine of 0 is 0. So our final answer is square root of 2 over 2. All right, guys, thanks so much for watching.